Our next example is another type of weighted mean, a GPA calculation. In example 8, it says to find the weighted mean. At the end of his first semester at Roane State, Trent had the following grades. So they show for each of his classes how many credit hours each class had and the grade that Trent made in each class. And then we have this note that an A is given the weight of 4, a B a 3, a C a 2, a D a 1, and an F is 0, and we're supposed to calculate Trent's GPA and round to 2 decimal places as needed. So we need to determine what our random variable x is, and we need to find our frequency list, right? The weight for each of his classes. So we have letters here. We can't calculate with those, but we've been told that the equivalent numerical number for each letter. So we can make our column here, and the grade is Trent's random variable x. So I'm just going to make an x here and list the x's. And so for a B, that translates to a 3. An A is a 4, so a 3 here, and a 2 for C, and a 2 for C. So those are the random variables x. That's what popped up, or what his outcomes were, right? His outcome for comp was a B, which gets the numerical assignment of a 3. So the weight of that B is given by the credit hours, as you probably already know. If you take a 1 credit hour course and make an A in it, that's not going to boost your GPA as much as if you take a 4 credit hour course and make an A. So these are our weights. In other words, this is our frequency list. That's where we'll put those values. Okay, so we're going to get in your TI 8384 calculator and stat edit, and I'm going to get mine ready. Okay, hopefully you can see that. So I'm going to let list 1 be my random variable x and list 2 be my frequency list. I like to make a note to myself. So list 1 is 3, enter, 4, enter, 3, enter, 2, enter, 2, enter. List 2, the freq list, 3, enter, 3, enter, 3, enter, 4, enter, 3, enter. Okay, and now we want to calculate Trent's GPA. So we go to stat calc, 1 variable stats, and list, that is our random variable x list. So I had that as I've noted up there in list 1. And I do have a frequency list. We don't always, but when we're calculating expected value or these weighted means, we do have a frequency list. And my frequency list was in list 2. And we calculate. And of course, the weighted mean is the same as what we're given as the mean here. X bar equals 2.75. It said to round to 2 decimal places. So we're already there. So Trent's GPA for that semester is a 2.75, right? Okay, let's look at example 9. And now we're finding the mean, mu, and the standard deviation, sigma, of this probability distribution. The random variable x is the number of houses sold by a realtor in a single month at Haynes Real Estate Office. Its probability distribution is as follows. So 0 houses sold, the probability is 0.01, 1 house sold in a month, 0.11, and so forth, all the way down to 6 houses sold in a month. Okay, so we're to find the mean and the standard deviation and interpret what this mean is telling us. Okay, so again, we go to our stat edit. I'm just going to move on to list 3 and list 4. So for list 3, this is my list 3. And list 4, these are the weights, the probabilities, the weight are the weights. Okay, so for list 3, I've got 0 through 6. 0, 1, 2, 3, 4, 5, and 6. Okay, for list 4, I've got the probabilities for each one of those. 0.01, 0.11, 0.12, 0.16, 0.24, 0.14, 0.22. Okay, and now we want to calculate the mean. Stat calc, one bar stats. So I have list 3 and list 4 this time. Second 3, arrow down, second 4, arrow down, and calculate. So it says the mean round to 1 decimal place, x bar is 3.81. So the mean is 3.8. And the standard deviation, let's see, the standard deviation, sigma, remember this, so this is considered for like a population. They don't even give us the sample standard deviation here. 1.6655, we're supposed to round to 1 decimal place, so sigma sub x is 1.7. Okay, and now we're supposed to interpret the mean. Remember what this is a long run or long-term average. So the long run average number of houses, the long run average number of houses sold per month is 3.8. That's the number of houses, right? Number of houses sold, the long run average. It's not supposed to be make sense in such that you wouldn't sell 0.8 of a house, but it's this long run average. It gives you a good feel. It's closer to 4 than to 3, etc. Okay, last question here. Would it be unusual for a realtor at the Haynes Real Estate office to have no sales at all in a particular month? And we're supposed to explain. Well, the probability that X is 0, no sales, was 0.01. So what's our answer? It's yes. And why? Because 0.01 is less than our cutoff 0.05, right?